Welcome to my channel. Today we will start trigonometry and the bearings. Our learning objectives are: find the trigonometric ratio of 0, 30, 45, 60, 90, 180, 270 and 360 degrees. Prove and apply the trigonometric identities. This is exercise 6.3 of class 9th based on the national curriculum of Pakistan. To measure the general angle, here I am showing you the coordinated plane. This horizontal line is called x-axis and the vertical line is called the y-axis. And this is the origin of this coordinate plane. This coordinate is divided into 4 equal parts. Each part is known as equivalent parts and each part is known as quadrants. This is the first quadrant and the second quadrant, the third quadrant, and it is your fourth quadrant. To measure the standard angle, we need the two rays with a common starting point. Here our first ray is on the x-axis. This ray is called the initial ray. And our second ray is the ray for which we have to measure the angle. This is called the terminal ray. To measure the standard angle in trigonometry, there is always a fixed reference point. So in coordinated plane, the fixed reference point is your positive x-axis side. So we will measure the angle from the x-axis towards the terminal ray into anti-clockwise direction. This is known as the standard angle. This angle is considered as the positive angle. But if we measure the angle in the clockwise directions toward the terminal ray, this angle is taken as the negative angle. Both of these angles are for the same terminal ray from the same initial ray, but in the different direction, in the clockwise and in the anti-clockwise direction. So both of these two angles are called coterminal angles of the terminal ray, the coterminal angles. What are the quadrantal angles? If the terminal ray of an angle in standard position coincides with any of the axes. What does it means? In the standard position, our terminal ray is start from the origin. This is our terminal ray and this should be our initial ray. So this should be the standard angle. But if our terminal ray is coincides with the axis, so if our terminal ray is coincide with axis, this ray is on the y-axis here. Either this ray is on the x-axis or on the negative side of the y-axis. So the angle between the initial ray and the terminal ray is known as the quadrantal angle. This angle is 90 degree. If we measure the angle from the initial side to this terminal ray, this should be 180 degrees. Similarly, if we measure the angle to this terminal side, which is toward the negative y-axis, it is 270 degrees. So these angles are called 90 degree, 180 degree and 270 degree are known as the quadrantal angles. Here's another term, unit circle. What is a unit circle? A unit circle is a circle having the radius of 1 unit. So it means that the distance from the origin to the point is always 1 for a unit circle in the coordinate plane. So in the coordinate plane, this point P is x distance away from the origin in the x direction and y distance away from the origin in the y direction. So the coordinate of these points are x and y. If we construct a triangle here, this distance is equal to the y and the horizontal distance is equal to the x and the hypotenuse value is equal to the 1. The right angled triangle is easily solved by using the Pythagoras theorem. In the Pythagoras theorem, that the hypotenuse square, the square of 1, this is the value of hypotenuse. The 1 square should be equals to the square of the base of the triangle plus the square of the perpendicular of the triangle. And x square plus y square is equals to 1. This is known as the equation for the unit circle in the coordinated plane. Here we will learn about the trigonometric ratios. Here is a right angle triangle and the C is equals to the 90 degree, and here is the A vertex. The angle is theta here, and this is the B vertex of the triangle. In the right triangle, this side is known as the base of the triangle, and the side in front of the larger angle, that is the 90 degree, is known as the hypotenuse of the triangle, and the side which is the vertical side in front of the angle A, which is coincide with the baseline, this is known as the perpendicular. So there are 6 possible trigonometric ratios that we can create. First we will name these trigonometric ratios, as we already given the name base, perpendicular, hypotenuse, but we will give us symbolical names. So the side in front of the B vertex is called B. Similarly, this side is C, and this side is known as the A side. So there are 6 possible trigonometric ratios. First, let's suppose we have a perpendicular. If we divide the perpendicular with the hypotenuse, that is our first ratio. And if we divide the perpendicular with our base, this would be our second ratio. We can also divide the base with the perpendicular and the base with the hypotenuse. Similarly, we can also divide the hypotenuse value with the base and the hypotenuse value with the perpendicular. So these are the 6 possible trigonometric ratios. Now we have to name these trigonometric ratios. So we know that if we divide the perpendicular with the hypotenuse, this ratio is known as sine of theta and written as sine theta. And if we divide the base with hypotenuse, this ratio is called cos of theta. And if we divide the base with the perpendicular, then this ratio is called tan of theta. And the other ratios are, when we divide the perpendicular with the base, this ratio is known as cotangent theta. And if we divide the hypotenuse with the base, this ratio is known as the secant theta. And if we divide the hypotenuse with perpendicular, this ratio is known as cosecant theta. Sine theta and cosecant theta are reciprocal of each other. Similarly, the cos theta and the secant theta. The secant theta is a reciprocal of cos theta, and cot theta is a reciprocal of tan theta. So these are the 6 trigonometric ratios related with the sides of a triangle. Now after defining the trigonometric ratio, we will find these ratios with the help of the unit circle. Here is the unit circle. Its center is at the origin point of the coordinate plane, and here is our triangle. So this is the point P on the circle line, and this is the origin, the starting point of our circle. This distance is equals to 1 unit because we are using the unit circle here. And in a coordinated plane, the P is at x coordinate and y coordinate. So it is x distance away from the origin in the x direction. The point P is y distance above from the origin in the y direction. So this length is equals to y. So here is our right angled triangle. To solve this right angle triangle or convert this x and y, the coordinate, in terms of the trigonometric ratios, we will use the trigonometric ratios that we are defined previously. As we defined, the sine theta is equals to perpendicular divided by hypotenuse. So here the perpendicular value is equals to y and the hypotenuse is equals to 1. So that implies y is equals to sine of theta. Similarly, the ratio, trigonometric ratio cos theta is equals to base divided by hypotenuse, and base is equals to the x and hypotenuse is equals to 1 unit. So x is equals to cos of theta. So now our point P in terms of the trigonometric ratios is, as P is equals to x and y, so we will replace x and y with the sine and cos. So P point is equals to sine of theta and cos of theta. To measure the value of sine theta, we want to measure the value of y, and to measure the value of cos theta, we have to calculate the value of x. Similarly, to calculate the value of the tan theta, as we know, it is equals to perpendicular divided by base. Here y is our perpendicular and x is our base. So tan theta is equals to y divided by x. When we measure these three trigonometric ratios, sine theta, cos theta and tangent of theta, then other three ratios are the reciprocal of these three ratios. So we can calculate all the 6 ratios if we will measure the value of x and the value of y of a unit circle triangle. First we find the trigonometric ratio of 30 degrees. Now here is our unit circle. The unit circle having the radius of 1 unit. So our O and the P side value should be equals to the 1 unit. The remaining 2 sides are unknown to us, the x and y. First we have to calculate x and then y. But the angle should be 30 degree here. From the geometry, we have to know that the angle in front of 30 degree should be half of the hypotenuse. If the angle is 30 degree, then this side, this y side, should be half of the value of the hypotenuse. If the hypotenuse value is 1, then this side should be 1 divided by 2. So if the angle is 30 degree, this side should be half. So by using this knowledge, we have to know the one side of the triangle, which is y, and it is equals to 1 by 2. By using the equation of the unit circle, x square plus y square is equals to 1, we can calculate the value of x. To calculate the value of x, put the value of y here. Now x is equals to under root 3 divided by 2. The value of x is under root 3 divided by 2. And as we already know that sine theta is equals to the value of y. Here the value of y is 1 by 2. The cos theta is equals to, theta is equals to 30 degree. The cos theta is equal to the value of y, which is under root 3 by 2, and tan 30 degree is equals to y divided by x. So 1 by 2 divided by under root 3 by 2, we will get the value of tan 30 1 over under root 3. Similarly, the other three ratios we can calculate. The sine, the cosecant 30 should be the reciprocal of sine 30 degree, so its reciprocal is equals to 2. Similarly, the secant 30 degree is the reciprocal of cos 30, which is equals to 2 over under root 3, and the cot 30 is the reciprocal of tan 30 degree, which is equals to under root 3. So in this way we can calculate the trigonometric ratios with the help of our unit circle equation. Similarly, we can calculate the trigonometric ratio for angle of 45 degree. But here we need the help of the geometry also. If one of the angle of a triangle is 45 degree, then it should be an isosceles triangle. What does it mean? It means that the both sides of the triangle should be equals. It means that x side should be equals to the y side. So with the help of this information, we will calculate our x and y. As we know that it is a unit circle, so our hypotenuse is always equals to 1. By using the equation of circle, x square plus y square is equal to 1, as both of the sides are equal, so substituting y is equals to x, we will get the value of x. So 2x square is equals to 1 and x square is equals to 1 by 2, so x is equals to 1 over under root 2. As y and x are equal, so y should also be equals to 1 over under root 2. So we know that cos 45 degree is equals to x, and the value of x is 1 over under root 2. Similarly, the sine 45 degrees is equals to the y, and the value of y is 1 over 4 under root 2, and the tan theta, the tan 45 degrees is equals to y divided by x. So 1 over under root 2 divided by 1 over under root 2, so both cancel each other, the answer is 1. So tan 45 degrees equals to the 1, and the rest of the three ratios you can find easily by taking the reciprocal of all these three values. Secant 45 degrees is equals to the reciprocal of cos 45 degree, which is under root 2. Similarly, cosecant 45 degrees is the reciprocal of sine 45 degree, which is under root 2, and cot 45 degrees is equals to the reciprocal of 1, which is equals to 1. So in this way you can calculate all the 6 trigonometric ratio by using the unit circle. Now find the trigonometric ratio for angle of 60 degrees. As in case of the 60 degree, if this angle is 60 degree and this angle is right angle triangle, this should be the 90 degree angle, and the sum of all the internal angle of a right angle triangle or any other triangle should be 180 degrees. So this angle should be equals to 30 degree. If this angle is 30 degree, then according to the geometry, the side which is opposite to the angle 30 should be half of the hypotenuse value. So here x is already known to us with the help of geometry. We need to calculate y only. So here I will only calculate the y, and the rest of the thing is your assignment. So x square plus y square is equals to 1. This is the equation of unit circle. So putting the value of x, it is 1 over 2 square plus y square is equals to 1. So y square is equals to 1 minus 1 over 4, which is equals to 3 by 4 y square, and taking square root both the side, 3 under root divided by 2. This is the value of the y. So you can calculate the sine 60 degree, which is equals to y under root 3 by 2. Similarly, you can calculate the cos 60 degree, which is equals to 1 by 2, and you can calculate the tan 60 degree, which is equals to y divided by x, and it will be equals to under root of 3. The remaining three ratios you can calculate, and it will be your assignment. Now let's discuss the sign of trigonometric ratio in the 4 quadrants. In the first quadrants, as you know that this is our coordinate plane, the x-axis. This is the negative side of x-axis. This is the positive side of y, and this is the negative side of the y. The first quadrant is here. In this quadrant, both values, the value of x and the value of y, both values are positive. So it means that in the first quadrant, the sine theta is positive, the cos theta is positive, the tan theta is equals to y over x, because y is positive when x is positive, so it is also positive, and their reciprocals are also positive. So all 6 ratios are positive in the first quadrant. Now let's see in the second quadrant. In the second quadrant, here x is negative and the y is positive. So the sine theta, because sine theta is equals to y, which is equals to positive value. Similarly, the cos theta is equals to x, and our x is negative here, so value of cos theta is negative in this quadrant, and tan theta, because tan theta is the ratio of y divided by x, and y is positive but the x is negative, so the overall answer is the negative answer. So these three ratios, sine is positive, cos negative, tan is negative. Similarly, if sine is positive, then cosecant theta, the reciprocal of sine, is also positive. The reciprocal of cos theta, which is the secant theta, is negative. The reciprocal of tan theta, which is cot theta, is also negative. Now in the third quadrant, as in third quadrant, the x is negative and the value of the y is negative, so cos theta is negative here, sine theta is negative here. But as you know that tan theta is equals to y divided by x, so negative y over negative value of x, so both negative cancels each other, and sine theta is positive in the third quadrant. So the similar behavior for their reciprocals. Here cosecant theta is negative, secant theta is negative, and cotangent theta is positive, as tan theta is positive here. So now the last quadrant, the fourth quadrant. In the fourth quadrant, you know that the y is negative but the x is positive. So here cos theta is positive, sine theta will be negative, tan theta will be negative, because it is the ratio of y over x. So if one of them is negative, the tan theta is negative, and their reciprocal, the cos theta, is positive, so their reciprocal is also positive, so secant theta is also positive here, cosecant theta is negative here, and cot theta is also negative in the fourth quadrants. This is more related to practical problem. We have to evaluate the other ratios if one of the ratio is given to us. For example, if sine theta is equals to under root 3 by 2 is provided to you, and the task is you have to calculate the remaining ratios with the help of this information. So sine theta is equals to under root 3 by 2. As we know that sine theta is equals to perpendicular divided by hypotenuse, so the perpendicular is equals to under root 3 and hypotenuse is equals to 2. So draw a triangle here, a right triangle, and label these values on the triangle. So this is the perpendicular, so perpendicular is equals to under root 3 and your hypotenuse value is equals to 2. This side, the base is missing to you. To calculate the base, you use the Pythagoras theorem. As you know that the square of hypotenuse should be equals to the perpendicular square plus the square of the base. So with the help of sine theta under root 3 by 2, we get the information of perpendicular and hypotenuse, and now we are putting the values here. 2 square under root 3 square should be equals to the value of the base square. So 4 is equals to 3 plus base square. So 4 minus 3 is equals to base square, and base is equals to 1. Now we have all three sides of the triangle. So as we define the trigonometric ratio, the 6 trigonometric ratios, and we name those trigonometric ratios, with the help of those names we can calculate all the other ratios. For example, the sine theta is equals to perpendicular over this, but we also know that the cos theta is equals to base divided by hypotenuse. The value of base is now 1 and hypotenuse is 2. So sine theta, with the help of sine theta we calculate the cos theta, And now we can calculate the tan of theta, which is equals to perpendicular divided by base, so under root 3 divided by 1. And remaining 3 ratios you can calculate by taking the reciprocal of these 3 ratios very easily. So calculate the other 3 ratios by yourself. Here we will calculate the trigonometric ratios of an angle if one of them is given. Previously we have calculated the value with the help of Pythagoras theorem and a triangle. Now we will use another method for the same information. As we know that sine theta is equals to under root 3 divided by 2, and we have to find the rest of the trigonometric ratios. Now we will do this with the help of our unit circle equation, which is equals to x square plus y square is equals to 1. Now we will evaluate the same trigonometric ratios if one of the ratio is given to us, and we will calculate the other ratio by the second method. We know that the sine theta is equals to under root 3 divided by 2, and here we know that in the circle this P point is x and y. Further we know that this y is equals to sine theta and this x is equals to cos theta. In the unit circle, the hypotenuse is always equals to the 1. So here we know that sine theta is equals to under root 3 by 2. So sine theta is also equals to y. So y is equals to under root 3 by 2, because sine theta is equals to y. So by putting the value of this y into the unit circle equation, we will get the value of x. So x square plus y square, which is under root 3 divided by 2 square, is equals to 1. By solving this equation, you will get the value of x, which is equals to 1 over 2. So you have the value of y and you have the value of x. So you can know the cos theta is equals to 1 over 2. The tan theta is equals to y over x. So y is 1 over 2 and x is under root 3 by 2. So it will be 1 over under root 3. And now we will calculate the remaining ratios by taking the reciprocal of sine theta, which is cosecant theta, and cos theta, the secant theta, and the reciprocal of tan theta is cot theta. Hope you understand the second method. It is much easier from the method number 1. Here we evaluate the trigonometric ratios of quadrantal angles. As you know, what is a quadrantal angle? The quadrantal angle is the angle when your terminal ray is on the axis line. So here our terminal ray is on the x-axis line. So terminal ray is on x-axis line and our initial ray is on axis line. So the angle between these two rays is exactly equal to 0 degree. So here is our O, the origin of the coordinate plane, and this is the point P on the circle. The distance between O and the P is equal to the radius of the circle, and which is equals to 1. So on the x-axis line, keep in mind that on x-axis line the value of y always 0. So here the x value is 1 because it is x distance away from the origin, and which is equals to the unit circle radius, which is 1. So 1 is the x coordinate and the y coordinate is 0. So x is 1 and y is 0. As we know the trigonometric ratios in terms of unit circle, we know that the sine theta is equals to y, and we also know that the cos theta is equals to x and tan theta is equals to y divided by x. So the value of x here for the sine 0, the value of y is 0. Similarly for cos 0 degrees, the value of x is equals to 1. So cos 0 is equals to 1 and tan 0 degree is equals to y over x, which is equals to 0 over 1 and which is equals to 0. Now the remaining 3 ratios, which is the reciprocal of these 3 ratios, the sine theta, the reciprocal of sine is cosecant 0 degree. So reciprocal of 0 is infinity. Similarly, the reciprocal of cos theta will give you the secant theta value. The reciprocal of 1 is 1. And the reciprocal of tan 0 degree, the cot 0 degree, the reciprocal of tan 0 degree is 0, is also equals to infinity. So these are all the trigonometric ratios for the quadrantal angle of the 0 degree. Now we can calculate the value for the trigonometric ratio of 90 degree. Now let us calculate the trigonometric ratio for 90 degree. So to calculate the value for the 90 degree, because our terminal ray is coincides with the y-axis, and with the initial ray it is making the angle of 90 degree. Here is our point. The distance from the origin is 1 because we are using the unit circle. On y-axis the value of x should be 0. So point P is here, its x coordinate is 0 and its y coordinate is equals to 1. By using the trigonometric ratio in terms of unit circle, we know that sine 90 degree is equals to the value of y, which is 1. Similarly, the cos 90 degree is equals to the value of x, which is 0 degree, and tan 90 degree is the ratio of y over x, and y is 1 and x is 0, which is equals to infinity. And the reciprocal of sine theta is cosecant 90 degree, which is the reciprocal of 1, which is always 1, and the reciprocal of cos 90 degree is the secant 90 degree, which is equals to infinity, and the reciprocal of infinity is equals to 0, which is equals to cot 90 degree, and that is equals to 0. Similarly, you can find the other values. Here I only show you the value of x and y. The remaining thing you will calculate yourself. The trigonometric ratio for 180 degree. Now 180 degree, our terminal ray is on the negative side of the x-axis. So here is the origin and here is the point P. The unit circle with respect to coordinate plane, the value of this unit circle is now taken as negative because it was in the towards the negative line of the x-axis. But on the x-axis line, as I told you earlier, that P is equals to negative 1, the value of x, and y should be 0. In a coordinate plane, the coordinates of x is minus 1 and here it is equals to y. Now by keeping the same method as I performed for the 0 degree and for the 90 degree, you can calculate the values of all the 6 trigonometric ratios here. Similarly, you can solve the values. You can solve and calculate the value of 270 degrees as our terminal ray is now towards the negative y-axis. So here the O and the P distance again equals to 1, and our point values are, because on the y-axis line our x value is 0 and our y value is negative 1 here. So this is the x value and this is your y value, and this is the terminal ray in the red color, and from the initial side if you measure the angle it will equals to 270 degrees. Now with the help of trigonometric ratio in terms of unit circle, you can solve all the 6 ratio as we solve in the 0 degree and for the 90 degree. The same method is applied here, so you can do it very easily with the help of the value of this point. To calculate the trigonometric ratio for 360 degree, it is same as we calculated the value in this video for 0 degree. So it will be very easy. It's your assignment. You can do it very well and very easily. This is our first question and we have to complete the tables. The value we already calculated in this video, and just we have to put that values in this table here. And this is the 6.3 exercise, the first question. But I will tell you a way how will you memorize this kind of table easily. First you will write here the 1 and 1, and then write here under root 3. If you write under root 3 here, then write these values in the reverse order here. So under root 3 here, then 1, and then again 1. Now divide all these values with the 2. And now the values in the middle, take the under root of these values. So in this way you can fill these two lines. So when you easily fill these two lines, you can divide y over x. So y is sine theta and x is the cos theta. If I divide 1 over 2 over under root 3 over 2, I will get 1 over under root 3. So dividing these two boxes, I will get my third box, which is a tan theta. Dividing these two boxes, I will get answer 1. Dividing these two, I will get the answer under root 3. Now these three ratios are the reciprocal of above ratios. So sine theta, cosecant theta is a reciprocal of 1 over 2, which is 2. Cosecant theta is a reciprocal of cos theta, which is 2 over under root 3, and cotangent theta is a reciprocal of the tan theta, so it is equals to under root 3. Similarly, I will fill the other two lines. So cosecant theta, the reciprocal, under root 2, under root 2 and 1. Here the reciprocal of sine theta, 2 under root 3, the reciprocal of cos theta, 2, the reciprocal of tan theta, 1 over under root 3. If sine is 0 here, then it should be equals to 1 here. So if it is 0 at 0 degree, it should be 1 at the 90 degree. It will be the opposite. And similarly the cos, if cos is 1 is here at the 0 degree, then cos should be 0 at the 90 degree. So tan theta is equals to y over x. If we divide y over x, 1 divided by 0, this will give you infinity. Cosecant theta, secant theta is a reciprocal of 1, which is equals to 1. Secant theta is a reciprocal of 0, which is infinity. Cot theta is a reciprocal of infinity. The reciprocal of infinity is 0. So in this way you can fill this table. So now let's come to 180 degree. The line of the 0 degree should be remembered to you. If sine 0 is 0, then this 180 degree should be opposite to that. If 0 multiplied by minus 1, so 0 multiplied by minus 1 is equals to 0. 1 multiplied by minus 1, it is 1. 0 minus 1, so 0 multiplied by minus 1, it is 0. Infinity multiplied by minus, so it will be infinity. 1 multiplied by minus 1, and then again infinity. So in this way you can fill up this. Similarly, as 0 multiplied by minus 1 will give you 180 degree. Similarly, if you multiply 90 degree with minus 1, you can complete the column of 270 degree. So if 90 is multiply 1, minus 1, 0, infinity, minus 1, infinity and the 0.